As we are determining or analyzing the truth values of conditional statements, and a conditional statement is in the form of if-then, where we've got if and a hypothesis, and then a conclusion. In analyzing the truth value of a conditional, we can sometimes run into some rather bizarre situations and things that would not appear to make a whole lot of sense. And this is where we're just going to have to follow our rules of a conditional statement. In other words, P is the hypothesis, Q is the conclusion, and if the hypothesis, then the conclusion. And here in this truth table here, if both the hypothesis and the conditional are true, then the conditional statement is true. And interestingly enough, if you skip the second row, if the hypothesis is false, but the conditional is true, the conclusion is true, we consider this conditional statement true. And oddly enough, if both the hypothesis and the conclusion are false, then we consider the statement to be true. That's one of the oddities. And then second, so the only time that we really have a situation in a conditional statement that the conclusion, the analysis would be false is if the hypothesis is true, but the conclusion is false. Now, if a statement is not false, then logic dictates that it must be true. But then also remember that we can render a statement false if we can find a counter example. Anyway, so let's look at this first one here. If angle A is an acute angle, then the measure of angle A is 35. All right, well, I don't really know if angle A is an acute angle or not, but then logic indicates that that would be true. So we're going to say the hypothesis is true. But what about this conclusion? Does it automatically follow then that the measure of angle A is 35 degrees? Well, measure of angle A being 35, if it was, that would certainly be true. But I don't really know that the measure of angle A is 35. Now, if you flip that around, did a converse of that statement, if the measure of angle A is 35, then angle A is an acute angle, that would both be true. But I could come up with a counter example to this. What if the measure of angle A was, 75? So then the conclusion would be false. And so since we can give a counterexample to the conclusion based upon the hypothesis, then we have to say that this statement is actually false. So when we're analyzing conditionals, do not try to determine whether the statement makes any sense. Just analyze it based upon the argument. So this is a situation where we just have to follow the rules of analyzing a conditional statement, which is given by this truth table. Now let's look at one that's even more bizarre, if you will. So here again, we're asked to determine the truth value of this conditional statement. If true, explain your reasoning. If false, give a counterexample. So we start off with the hypothesis. If the square root of x is -1, well, the square root of x cannot equal -1. So that is a false statement. Now, look right here. Just the fact that just by virtue that the hypothesis is false, we're going to say the conditional is true. Now, if that's not bizarre, I don't know what to tell you. But let's go ahead and look then at the conclusion. Then the square root, then -1 squared equals -1. Well, I know that to be false too. negative 1 squared is positive 1, not negative 1. And so since, here we are in bizarro land, since both the hypothesis and the conclusion are false, guess what? We consider the conditional to be true. Does that make sense? No. Are we basing that upon the rules of conditional statements? Yes. Ours is not to question why. Ours is but to do and die. Half a league, half a league, half a league onward.